So go ahead and draw that from negative 2 pi to 2 pi. This is a basic cosine graph. We got 0, pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Now to the question, some background that you'll need in order to answer part 3. So we have an interesting dilemma here. We want to talk a little bit about inverses. And inverses are a topic we discussed in Unit 2. And there were two important properties we talked about. So the first one was a function has an inverse if it passes the horizontal line test. So we said inverses, function only has an inverse if it passes the horizontal line test. And just some background again on why that happens is because we want functions to pass a vertical line test, so only if they pass a line test will their inverse actually be a function. Now we have a slight problem with cosine. If I draw these horizontal lines, I do not pass the test because I touch the graph in more than one spot. We have a slight problem here. And we said in Unit 2 that if we had such a problem, so if a function fails the horizontal line test, if a function were to fail the horizontal line test, we could restrict the domain. You all might remember the domain restrictions. We can restrict the domain, so a function passes the horizontal line test. So a function passes the horizontal line test. So we will have to employ that strategy here. Before I discuss how to employ it, let me see if there are any questions, give people a chance to catch up. Do I need to move it up, Nomi? Okay. So let's assume, for discussion purposes, that I restrict the domain from 0 to 2 pi. I'm not successful. I still fail the horizontal line test. Okay? What if I said, alright, instead of going to 2 pi, I'll go to 3 pi over 2. Still failing. But if I go from 0 to pi, I'm in good shape. Because from 0 to pi, what happens? I don't fail the horizontal line test, and I get every possible y value, all the way from -1 to +1. In other words, in this little shaded area here, I pass the horizontal line test, and every possible y value occurs. I have everything from -1 to +1. So the domain restriction for cosine is from 0 to pi.
So it should be done between periods?
No, because remember the period is 0 to 2 pi. Now, I could have picked, please notice, I could have picked what I'll shade in red. In other words, I could have picked this side. from pi to 2 pi. That would have done the same thing. I could have picked from negative pi to 0. You can keep it.
Oh, I wrote it on my notes.
That's fine. I could have picked from negative pi to 0. I could have picked from 0 to pi. I could have picked from pi to 2 pi. In fact, there are infinite domain restrictions I could have picked. The convention in math, what has been agreed upon, what everybody uses for cosine is from 0 to pi. Not that this is wrong, it's just not the convention. The convention is we drive on the right side of the road. Driving on the left is not inherently wrong. It is just if you did that, you would likely have an accident. Using this domain restriction is not inherently wrong, but if you do, you will have an accident, i.e. miss the question. So, the point of this monologue is the following. The domain restriction for y equals cosine of x is from 0 to pi. Now, why is the domain restriction needed? We'll discuss that and why it's helpful in about 3 minutes. I need to do 2 other things before we get there. Before I do the 2 other things, which are the exact same analysis for tangent and sine, let me see if there are questions on this. Okay. Let me conduct the exact same analysis now for the sine graph. So, you know what I mean?
So you said if we do the negative pi to 0, that would be wrong?
That'll be wrong. Yeah, exactly. So now let's look at y equals sine of x. Go for it. So here we are, sine graph. And again, we look, and unfortunately, we are failing this test. So, I start to see what I can do. I say, let me just look from 0 to 2 pi. Still failing. I say, let me just look from 0 to 3 pi over 2. Still failing. I say, let me look from 0 to pi. Still failing. 0 to pi over 2. We're good now. But there's a slight problem. If I do 0 to pi over 2, I only get half the y values. I don't get this part. So I better add this in too. So the domain restriction for sine is negative pi over 2 to positive pi over 2. The domain restriction for sine, let me rephrase, y equals sine of x is negative pi over 2 to pi over 2. Again, there are many other intervals that are not technically wrong. For example, pi over 2 to 3 pi over 2 is technically not wrong. It's just not the convention. You know what I mean?
Can you see why is that the domain restriction here?
Yeah. So we have to have some restriction on the domain so that 2 things happen. 1, I pass the horizontal line test, and 2, I get every y value. Right? So I kind of started here, and I'm like, okay, let me keep going back, not far enough, still a problem. I'm like, this is really nice, right? Like, there's no, like, here I pass, but the problem is, I only have half of the y values. So I need to add in the other half of the y values, because this only goes from 0 to positive 1. I need to go from negative 1 as well. So I got to add this part in. So now this becomes the domain restriction, negative pi over 2 to positive pi over 2.
Why do you need to add that?
because I need to get all the y values, I can't just pick the positive ones, right? So I need to have the negative y's also. Finally, let's do the same analysis for tangent. I don't need to belabor the point. Yes, Atlantis?
Which of these are we doing?
Right, so this is kind of background information that will prepare us to answer part 3.
Oh, okay.
Okay, so let me draw tangent. So tangent kind of comes up like this, comes like this. Got these asymptotes here. Then again, another asymptote. Then again, another asymptote. Then again. I mean, I could keep drawing this forever. But tangent looks like this. And we start to have some problems because, oh boy, we're going to fail. So, we do what we always do, trial and error. Eventually we'll succeed. So, I start here. Nope. Still a problem, still a problem, still a problem, still a problem. We're good here, but only get half the y values. Right? That only gives me half the y values. Let me get a darker color. Whoop, this is the same color. So, this is only half. I better expand and get all this as well. So I can get the negative values and the positive values. So for tangent, the domain restriction is just like sine, negative pi over 2. Domain restriction is from, this is key, please do not put brackets. Why? Because we have asymptotes at negative pi over 2 and positive pi over 2. The function is not defined there. So let me stop, let folks catch up, then we'll jump right back with problems A, B, and C on page 3. Okay, let me put that. Huh? That's just the convention? Yeah.
Okay.
Better? Oh, now my hand is causing problems.
So if you do any one of the part areas? Like, if you
Right,
can
so,
do one?
I mean, you could, right? And like, if you pick this from like pi over 2 to 3 pi over 2, it's not wrong. But, again, the convention is to do this. So you
Okay.
should use this on the problems. I'm going to show you why from here.
So we should always aim for it to be on the 0, like it.
Yeah, maybe that's a good way to think about it. You should always include 0. Maybe that's a good way to think about it.
Okay. Yeah.
But I mean, like this is what it is. Like, you can just, like, commit this type to memory now. Like, it's not, like, this will never change. This will always be what the domain restrictions are. Okay, so let's jump in with A, B, C on page 3. All right. Here we go. You guys are doing great. It's a long day, but we're almost there. You think this is the second to last day I'm teaching for the semester, so we're almost there. Next Tuesday is the last day I'm teaching for the semester. So, problem A. The rest of the days are just you all working. So, we're trying to find this. And this looks like